Hello and welcome back to Doz's Television Workshop. More VIC-20 shenanigans are afoot. We need to take a good look at what's going on with the Hyper Expander because it's not working as it should. And mistakes were made during the build. It's all my fault. Okay, you'll remember this from the VIC-20 video and its own video. Now, if you go back onto its own video, you will watch me assembling this thing, and nobody so far has spotted that this, on the right hand side, is a double footprint. So you can have a chip, let's get one, hang on. You can put in an EEPROM or a RAM chip in there just by moving it across like that. And what I did, because I wanted the 37 kilobytes of RAM, is I soldered a RAM chip in there. And like the idiot I am, didn't pay attention, and I soldered it into the EEPROM position. Now, the difference in pinouts between a 62256 and an ordinary 27C64 EEPROM, for example, isn't that much. We've got a programming pin, obviously, on the EEPROM. But when we tested this unit, we couldn't get any more than 3K expansion. And we should be able to go to 37. So something's happened. So what I've started to do, as you can see, I've desoldered the two RAM chips, pulled the EEPROM, and I've also desoldered the two 148 gates. And I thought I had one here. I think it's over here. Anyway, one of those, brand new that it was, tested faulty. So it's either failed or we've damaged it. So I then ordered some sockets. Chip sockets are getting very, very difficult to get again at the moment, like everything. But we've managed to find some. Sadly not turned pin, but they will be absolutely adequate for this job. So this time we're going to pop the RAM into the right holes. Two new 148 logic there, 74LS148, and fire it back up. Hopefully we haven't done it any damage. Now, in testing things, you'll remember when we did the VIC-20, I built this 2114 static RAM tester. Now, inspired by that, I have built a 62256 static RAM tester. There is a few designs on the web for this particular thing, none of which I liked because the common ones seem to use an Arduino Mega. And I wanted to do it that evening. So they use a Mega because you haven't got enough pins on an ordinary Arduino for 15 address lines to give you 32K plus the 8 data lines. So what I've done is the Arduino actually just steps up these two ripple counters. So these actually give us 16 bits, so it actually do 64K. Of course, the chip isn't, so it's pointless. But yeah, so the Arduino actually increments this address counter, if you like, loads that into the memory. It then writes every available 8-bit pattern to the memory, reads it back, makes sure it's all right, then moves on to the next address. Now, by my calculations, I think that's 16 million operations because it's 32768, that's our 32K, times 8, and then it all does it all twice. So I think it's 16 million operations. So this does take a long while to test our chip. Also, something I was thinking I might add to this one actually. It also comes up with a go, no go. This green LED here. In fact, let me show you. I've got a chip here. So let me just push that into the tester. Oh, and I've buckled one of the pins. Oh. Look at that. Buckled straight up. Careless. Very careless. Let's straighten him up. Should have used the leg tool. Right. So, yeah, it goes in this way round. These are actually brand new Samsung chips. Let me get a source of USB power. And plug this in. So when the tester's running, you'll see the green LED there is flashing. And these two LEDs are lit. The red LED is fail, the yellow LED is pass. These will both remain lit until 16 million read-write operations are completed. The green LED flashing, by the way, that is just a function of the address counter. So time will pass, and this will, I happen to know this IC already passes. I tested all of them when they arrived, so we know they're good. And I did build this tester because I thought, well, perhaps I've damaged some of the RAM on here, because I couldn't, I was concerned, obviously. So rather than just buying some more memory, which I had anyway, but yeah, I thought I'd test it, and sure enough, those two memory ICs had in fact had not been damaged by whatever we'd done. So it does look like it was just one 74LS 148 IC that failed. So what we're going to do, I'm going to mount this socket back in the right place, so we can socket the two RAM chips back in there. Also, the EEPROM, I did check and confirm in the programmer that this hadn't become damaged. So here's hoping that this will then work properly in the VIC-20 and make any further VIC-20 repairs we ever do again a little easier. We've certainly got an arsenal of test gear now to help us with that. So let's get those sockets mounted up and the board repopulated. Okay, there we go. So those are the sockets fitted. Now, if you actually, or if I in fact paid attention when we did this to start with, you can see there's a message there written on the silk screen saying hi RAM or second EEPROM. Silly boy. Right, there's a lot of, ooh, where are we? There's a lot of horrible flux on there. So we'll clean that up and plug it in and switch it on. Let's go. Right, you'll notice that the VIC is apart again, and with good reason. So our Hyper Expander is giving us 6K and no more. I have meticulously tested this board. I'm unable to find a fault with it. Therefore, I thought the only thing to do is to have another look at the VIC. Unfortunately, I did put a little plea out to see if anybody had a VIC-20 I could borrow just to try my Hyper Expander in it. Nobody sort of locally does. So that's a bit disappointing, but there we are. By the way, I will apologise, there's a 3D printer running in the background. I should come to that in another video, I should think. Anyway, so let's just step over to the schematic for one moment. You'll notice in a break from normal routine, I'm running Windows. That's simply because I've been using the logic test function of the TL866 Mark II to test our 74138s, and with good reason. Right, here's the diagram of the cartridge port here. Now, the pins I was interested in are 10, 11, 12 and 13, which couple back to UC5. Now these are the block selects. So it's block 1, block 2, block 3 and block 5. 0 and 4 do other things. These are the 4 block select lines that appear on the cartridge port. So I'm thinking for BASIC to see that bit of RAM, it's got to be contiguous. If we've got a block misalignment, then the only RAM that we can switch in is that 3K, which is switched in here. So what's going on? Okay, so let's just have a look on this side of the IC. We've got CA 15, 14 and 13. So we've got these 3 address lines, which correspond to a 6522 somewhere. So what I did is I switched over the 6522s, just swap them over, and there's no change. Didn't think it would be. So I'm coming back to this 74138 here, which decodes these lines. Now, that's why I had the logic test function here. They're all, as you can see, all vector testing normal. Of course, I've changed that already, UC5. Here it is. I've even swapped it over with this one. It made no difference at all. So I'm thinking, okay. So what happens if we've got a problem on these lines? So we've got pin 10, 11, 12 and 13 of the cartridge port. So naturally I'm going to start off with 10. Now I don't know which pin on the PCB this is, so I just put my probe on pin 14 of UC5 and I'm going to show you now. So right, I'm just going to zoom in a shade, I think. Right. Okay, so here's UC5. So we want pin 14 of that. So 1, 7, 8, 9, 10, 11, 12, 14. And what I did is I just moved my probe across here to find pin 10. There it is. I haven't pushed the beat range, have I? There we are. Let's try that. So just to find pin 10. There we go. So I'm thinking, okay, I'm presuming this is pin 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hang on, I've just beeped out 11. Pin 10. 11. Wait a minute. Those two are short. Now that's our block 1 and block 2 signal. And they're short circuit. So despite having tested the 138 previously, let's pull it out the board and measure between 14 and 13, which will give us the thing here. So sure enough, those two pins are short. They have no right to be. And looking carefully here, there's the tiniest bit of lifted print there. And I think what's happened is that's pulled out and is just touching the next pin along. It's the VIC-20 all along. So the next step, of course, is to remove this socket, put that wiring right, and try again. So let's do that. Right, okay. So I'm not going to use the desoldering gun to get that out. I'm going to use a bit of hot air. It's probably a bit kinder because this print's already in a bit of a mess. So let's get it hot with a hot air tool. I'm not particularly bothered if I damage the socket. There will be others. That's not hot enough. Let me turn the temperature up. Yeah, we're going. Starting to move. There it goes. Okay, let me just cool that gun down. That's it. Cool enough to go back in the rack now and just switch itself off. Right, let's have a little look and see where the damage is. So, you can see it straight away. I can see it straight away. Let me see if we can get a close-up up here. So, there we are. So if you just look there, you can see that print had lifted and short-circuited to that pin just to the left. What I'm actually going to do, I think, you can see that actually on camera, I'm trying to do my best here. There's the bit of print that's lifted. Look. Just goes to show you've got to be so careful with these boards. So I think we've got a via next to it. Yeah, we have. I think what I'll do is I shall remove that from print side and make it from that via, just a piece of wire straight to the leg on that side. That way there's no chance of any short circuit there. Right, let's make that repair and see where it puts us. So I'm going to need to get rid of the solder out of all those holes. Okay, so the dodgy bit of print is here. I'm just going to identify that via first. So how I'm going to do that is I'm going to float some new solder into it. And hopefully it'll melt the other side and I'll be able to see which one it is instantly. Looks to be the second one down on the right. Yep. Got one hole that didn't clear still. Lovely. Okay, so that's the via there. I hate an own goal. There is nothing worse. Right, using these tweezers, I'm just going to pluck that track off the board. There it is. It's gone. Actually, it's not quite gone. It's nearly gone. Brilliant. Now, is my chip holder salvageable? Probably. Let's use the universal vise. Alright, I am just gonna check, now we've taken that out, that was our fault. So I'm just going to pin out those two pins on here again to make sure they're not short circuit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. They're still short. How is that possible? Nine, 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13 and 14. Ah, don't tell me there's a short on that via there. Good Lord. Don't tell me. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. Oh, I don't believe it. So it wasn't under the socket after all. It was this via here. Ugh. I'm just going to show you that. Right up here. That must have been when we resoldered the RAM. I must have just bridged that bit. Oh, an own goal indeed. Okay, right. Back together it all goes. Okay, so I've got the Hyper Expander set out for flat out memory. Now that will give the VIC 37k, however, only 28k of that, or read about that, will be available to basic. So Ladies and gentlemen, moment of truth. Power. And bingo. 28159 bytes free. Brilliant. Let's reassemble the VIC again for the final time, please. And we shall test out some of the EEPROM functionality at long last. Excellent. Ladies and gentlemen, I've just put the board back into the bottom of the case, done the screws up, just plugged it in, switched it on, and I have got precisely nothing. So I'm just going to have a quick look at the power supply, and I've got precisely nothing coming in on the input socket, because my mains transformer has now failed open. It's just resisting repair at every turn. Yeah. So the one thing I have noticed is this power supply, it's quite warm actually. Now, can we get that apart and do it? Oh, there's a fuse in the end. I wonder if the fuse has failed. Oh, he lives in hope. Oh, it has failed. The worrying thing is, it looks like it failed for a reason. It is, or rather was, a 200 milliamp time-lapse fuse, time lag fuse I should say. Right, let's have a look in my box of fuses. 200 milliamp. Okay, we do have something similar in here. What are these? Doesn't say. You can see what I'm doing there. Right, here we are. So, what is that? 630 milliamp. Well, it's better than nothing, isn't it? Let's pop that in, try it, and I shall order some 200 milliamp fuses and fit one. Right, let's reconnect the mains. Simple as that. Was just a fuse. Right, I'll order up some 200 milliamp fuses to go in there. I mean, just why? Why would it do that to me? One of life's little mysteries. Perhaps something shorted on the bench, but I thought we were going to be in for a power supply as well then. It just doesn't want to be repaired, does it? Right, let's finish getting it back together. Okay, right. Now, the VIC-20's back together. God, I'm hoping for the last time. I really am. We're going to go through the settings of the dip switches. One thing to note, you'll notice a minute ago there was an EEPROM in there with a label on it. Turns out the EEPROM was too small, which is why I was getting my problems. They need to be 512, 27, 512 EEPROMs if you're making some more. So just keep that aware. So that is exactly what that is. So let's power up, and there we go. 3583 bytes free, which is a bog standard unexpanded VIC-20. So let's pop the 3K switch down. That should give us another 3 kilobytes of memory, so it should give us our 66 55 bytes. There they are. Now, if we assign block 5 to the first address in our EEPROM, so that's 13, 14 and 15 down and block 5 switch down, we will see that we've used up a bit of memory. We've now only got 6519 bytes free, and that's because, for example, if I press F1, we get the graphic command, draw, circle, paint, etc. And the sound on here somewhere as well, colour, sound, there you go. So those are part of the Super Expander, the Commodore Super Expander instruction set. So that's why that's loaded in. Let me just hit reset. So now we can go about adding some more RAM. Now we can't use block 5 because block 5 is being used by the EEPROM. So we can add blocks 3, 2 and 1 in, hit reset, and we should have just shy of 28. Yep, there we go. 28023 bytes free. And again, the Super Expander still loaded, which is great. Not only that, but if we go SYS 11 times 4096, that should run VicMon. Bingo. That is the VIC-20 monitor, Micro Monitor version 1.2, Bill Yee, 22nd of January, 83. I wonder if Bill Yee had any idea it would still be working all these years later. So there we go, that's a useful ROM. You can of course put the diagnostics on there. There's a RAM check. It's all manner of things we can put on this this EEPROM. But those are two really useful diagnostic tools. I'm going to keep those there. So that's what the Super Expander does for us. Let us now look at our homebrew C2 interface. Yeah. Okay, assembly of the C2 interface. So yeah, we've got some parts. We've got some parts from our reputable suppliers. We've got parts from less than reputable suppliers. We've got our C2N type plug. That's going to plug into our VIC PET or 64. I have noticed there's no keyway on here, so we do need to be a little bit careful. Right. We've also got the boards, of course, which were beautifully made for me by JLC PCB. Yeah, and you'll notice it was a minimum quantity of 5. I'm only ever going to want 1, I think. I'll also, of course, put the Gerbers and the design and schematic and everything up on the website at andydoz.blogspot.com. There you go. Right, let's build it up. There, what's that? That is all the surface mount components down. Didn't take long, doesn't take long at all. Right, so we want some pin header, which is up here somewhere. Sort of pin headers. What else will I need? I will need the pot's got to go on, pin header's got to go on, obviously this has got to go on. Yeah, right. Oh, LEDs as well. I want a couple of LED diodes, so I want some little ones. I'd really like some little green ones, so I'm going to look those out in a moment off camera, I think. Right, yeah, okay, so pin heads. I'm just going to see, J3 pin 1 is the VIC-20's ground pin. So actually, I need to look at the VIC-20 and work out here which pin is ground. just so we get this board up the right way. Yeah, so we don't end up with something we can't use. Right, bear with me one moment. Right, here's the Vic. Let me zoom out a little. Okay, so I'm just going to plug that in. Like I say, these aren't keyed. Saying that, I can't get it to fit. What's going on? Is it keyed? And I'm just making this up. Maybe it is keyed. Right. Either which way, I'm not quite sure on the VIC-20 which is pin 1. So it won't take much to find out. I'm just going to pick up an earth from the Hyper Expander. Which is that pin there. So pin 1 is ground. That looks very groundy. That one isn't. So both this end. So both of this end is pin 1. Excellent. Let me mark that there now. Pin 1 is that end. Now, the way I'm going to mount this, let's zoom back in again. Oh, wrong way. The way I'm going to mount this up is you'll see this connector has twice the number of pins. So it will sit that beautifully. What I'm actually going to do is bend these pins together with a little pair of pliers and then sort of slot the board in between the two so it fits together really nicely. Okay. Pin 1 is by our stripe, so it's this way up. Okay. Okay, coming together. Solder the other side pins, give it some physical strength. Alrighty. Pin header. Lots of pin header. I need a little bit of 3. Kicking about. That's in 3s. No, we haven't. Right, okay. Let's cut a bit off. This is the jumper for phase. I'm not entirely convinced we're going to need it. But we've implemented it anyway. So, hang on. That is going to be the wrong way up, isn't it? That's upwards, so we need to pop it in that way. Stick a bit of blue tack on it to hold it upright. It won't be. I am notoriously awful get pin headers in straight. I've probably mentioned that before. There we are. Okay, now we've got the 2 input and output sort of ports. I'm going to fit the pot while we're here. This pot came from TC Electronic Components. They're on eBay. They seem to be very reliable. So we're happy to use them. I know parts on eBay can be horrible. But TC Electronics, speakers you find, very good indeed. There we are. Okay, so let's pop the pot on. Right, and the input-output leads are the final thing. Now what I've got is just a cheap sort of car auxiliary lead that you used to get for your phone. So I've got a couple of 3.5mm stereo jacks on each end. Well, we don't want that, so we can just cut it in half. Where are my cutters? Oh, my strippers as well. There we are. Okay, so just cut it in half. Strip a bit of the insulation back. Let's have a look at what we've got in here. So we've got a red, a white, and the screen. Excellent. So let's just twist a bit of that back there. Okay, and I'll cut the rest of the screen off, otherwise I will never fit it through the hole. Lovely. I'm just going to do the same with the other half. And these leads are going to be for playback and saving, so we can record from our computer onto our MP3 player. And in fact, the VIC-20 title sequence, the program for that, I'm going to put right at the end. So, yeah, if you want to watch that, you can do. Watch that. You can record it off YouTube, put it on as an MP3 or whatever. Just, yeah, you can then load it in using your C2 interface. Or, of course, you could do it the old-fashioned way. Record it straight to a cassette and put it in a real one if you've got a cassette recorder. Okay. That's looking very nice. The two conductors, the red and the white. White is for left channel, red is for right channel. We're going to want to couple those together. So just strip them back. 1, 2. Ooh. There we go. Let's strip that back. I'm just going to tack those together. So, J2. J2 pin 1, which is the square, is our signal, I believe. It is. J2 pin 1 is the signal. That was silly, wasn't it? Normally pin 1 is ground in the world of electronics. Ah, well, this is one of those times that's exception that proves the rule. So we've got 2 of these to put in. One for saving and one for loading. Right. I'm just going to solder my ground up. Now I'm not going to push this through the board because it'll tend to chafe through the board and break. So what I'm actually going to do is tack it on the surface. You could of course put a pin header in there and maybe a Molex plug and crimp it all up nicely. I don't think I'm that fussed. Your mileage may vary. Right, that's looking lovely. So that side pin, round is ground, square is here. So Square is my signal. And pin 1 is ground. Ah, that's not helpful, is it? Really? Have I done that so badly? Ground is ground. Anyway, you can see from the board layout. Okay, that's one of them in. So a little solder up of the second, get it all tinned and ready. Or 3D print enclosure or whatever. I'd love to see that if somebody does 3D print a little enclosure. Again, I'm not sure I can be particularly bothered. Just trying to make that look neat. We will get there. That's the fella. Right, there's our two connectors on board. Let me find some 3mm green LEDs. I'm going to have to stop the camera and come back. Well, there we go. We've completed assembly of the C2 interface. I have to say the LED drawer wasn't quite as forthcoming as I thought it was going to be. That D1, which is our level LED, is a red one, apparently, in a clear lens. I've put a little link on there, so we can swap our phase about should the need arise. Not convinced, but well, I remain to be persuaded. So there we have it. That should then just plug into our VIC. Let's try it out. Okay, confession time. There has been a monumental snafu. If you look, the board is component side upwards, and there are two bodge wires. Let me zoom in a little. Oh, wrong way. Zooming in. Let's see if we can't get that a little in shot. And it's because I wired the op-amp power supply up backwards on the board. Clever boy. Yeah, man that never made a mistake, never made anything. However, having corrected that and replaced the op-amp, because the original one didn't like it, it now works. I will correct the Gerbers. Anyway, I've loaded a program onto the VIC. So if we save DOS, I am going to hit record on this little Tascam thingamabob here. We're recording. Click return. Level's quite high. So, ooh, can't see that. Let's go out a bit. There we are. There's our Tascam. It's what these voice recording things. Anyway, so that's recording, and yep, still saving. There we go. A bit longer than I thought. There we are. Right, that's saved that. We will reset the VIC. I'm going to shift run stop. I'm going to press play on that. The trick is with the LED, by the way, is to just adjust it so the LED is just on when you start to see signal. Right, so load searching. Found DOS loading. Hey, and as you can see, DOS's Television Workshop, that's the title sequence. If you're interested in loading this for yourself, by the way, you'll need the Super Expander installed. But I'll just leave the soundtrack on the end, right at the end of this video. And there we are. What use is this, I hear you saying? Well, one, we don't have to go out and get a cassette for our C2N. Our C2N may not be working. We can just record and save our programs to our Tascam or any other sound recorder. I've also got the old MP3 player that I've often used on this channel to demonstrate various bits and pieces. This works as well. It's just that when I came to film this, its battery's flat. So I thought, oh, right, okay. So yeah, we just fielded in this one, and it works very well. Also, of course, you could just use your headphone and line output jacks on your laptop, for example, and load and save straight from there. The other thing you can do is, so most VIC-20 programs you download from the internet are PRG files. Well, you can turn a PRG file into a wave. And having done that, save the wave out, or just play it back on your ordinary computer, set your level up so that LED's just coming on, and yeah, and your program will load. And to that end, let's have a go on the wonderful Jeff Minter's Grid Runner. Yeah. Okay, so the first thing we need to do is to download ourselves a copy of Grid Runner. So we've done that. I'm not going to show you where to do it because it's probably still copyright, and a mate of mine knows Jeff, and I don't want to upset him, but yeah, Google's your friend there. I'm sure Jeff doesn't mind. When did you write it, Jeff? 82, 83, something like that. Right. We need a program also called AudioTap. Now, as far as I'm aware, it's only a Windows thing, and we want to convert from a TAP file to a WAV file. I'm going to click on Advanced Options, and to be honest, I'm going to turn that down to about 200. Okay, so we're converting from a TAP file to a WAV file. Go. We go to our PC. I go to the downloads bit where I may or may not have downloaded Grid Runner. I click on Grid Runner. We click open, that's the tape file. Now it's going to ask me to name our WAV file. I'm just going to call it GR. We're going to save that. And that's it, done. Now we can drop that straight into our WAV file player, or turn it into an MP3, and you can store a lot of them in not a great deal of space. Ironically, it is a lot more space in memory terms than the VIC-20 is. Okay, I've got my crummy old MP3 player. I've put a bit of charge in the battery. Switch that on. And I've recorded my MP3 file. I did it as 256K, by the way. There we are. So, it's not that one. My bad. Gridrunner.mp3. There we go. Let's see what happens. Found Grid Runner loading. Fabulous. Now we have Grid Runner for the VIC-20. Brilliant. Let's have a little go on that. Oh, great little game. I just remember this is running in, well, an unexpanded VIC-20 of 5K. Brilliant. Still no good at it. What a great little game. Well done, Jeff. So, yeah, there you have it. Grid Runner for the VIC-20, downloaded off the internet and loaded into the VIC-20 using an inexpensive MP3 player and a cheap interface. There we go. That was good fun. I'm going to stay and play this for a bit. Stay tuned to Doz's Television Workshop, because coming up we've got a little bit of vintage electronics to get through. We've got a piano to repair. Yeah, there's quite a few things coming up, and then we'll do another micro in the coming months. So thanks for watching. If you want to download the wave off the end of this video, by the way, that will give you the VIC-20 title sequence. You will need a super expander ROM fitted in a hyper expander such as that, or a real super expander if you want. So you'll need that to run it, but there we go. Thanks for watching, and come back really soon to Doz's Television Workshop. Cheers, bye. Main computer, or let's just do this again because it's hand. And welcome back to Dozzy's Television. Let's do it again. And repair. Shot off into hyperspace. Come on, really? Perfect. Lovely. Thank you. Tascam 227 Radio Jackie. Right. Let's wait till Steve's finished with the saw, shall we? Could shut the window. Shut the window. It should give us variabus. No, it shouldn't. Start again. That'll do.